Good day, I'm Vincent Saxtetter, and this is the After the Age of Fire channel. This is episode 15, recorded on October 31st, 2025. This episode is about the end of coal, oil, and gas. The previous episode was about the end of oil, and now I'm taking it a step further to all the fossil fuels, coal, oil, and gas, to say what we can expect in terms of an end. To recap what the main idea of this channel is about, I'm trying to uh, give you some information about our current situation after 250 years of doubling our consumption every 22 years or so. We're using about 1,000 times more resources than we did 250 years ago. Divided that between around a factor of 8, factor of 10 more people, so each of us has around 100 times more resources per year, per day, than we did 250 years ago, and it's been multiplying every generation. We're coming to the end of the multiplication, and so I'm trying to describe what we can expect for the present as we're coming to the end. Are we already at the end? Is it coming soon? And then what to expect from the next 200 years as after we meet the end of this continual multiplication of our consumption of the resources on offer. And this is really a prepping channel. It's a channel not for prepping for the coming civil war next year or for the financial meltdown. Things like this will happen, but it's a prepping for a longer term survival of your family and your family line, um, how to have a thriving family, and how to find a way forward that is actually a positive way forward, that where things, at least for you and your family, are getting better and better, instead of not being able to live through the end of exponential growth. The fact is that for many thousands of years, the human race has been thriving, and long before this last 250 years, and we can continue to thrive after we end our multiplications. So that's what we're prepping for, how to make sure, how to not make sure, but increase the chances that your family line will continue and will do well. So in the last episode, we talked about oil in particular, and to recap, um, there is a physical limit to the amount of coal, oil, and gas on this planet. It's and but we never but we, that's not a relevant question. We don't really need to answer the question of how much there is, because we'll never mine it or pump it all. Um, we'll only mine or pump what is profitable to us. What what is, not just in terms of money, but what rewards us enough to compensate for all the problems that come with all the work and all the resources and all the other problems that come with consuming coal, oil, and gas. And so, and then one more complication. So really, what are we willing to do? That's the main question. How much will we leave in the ground, and how much will we pump and mine? And that really depends on us. Um, so, and I can only answer that question in the context of our current society, how we're set up now in terms of energy use. Right now, about 1/6 of our energy goes to mining and drilling, pumping, and getting more energy, refining. Okay, right now, that's fact number one. 1/6 of our energy goes to getting more energy, but right now only about 1/20th of our spending goes to getting more energy. In other words, we have a discount on energy right now. Energy costs 1/3 of what it would if you looked at how much energy you have to spend to get more energy. Um, it's cheap in some sense. It might not seem cheap to you, but it's a lot cheaper than energy was 250 years ago. Um, It's a lot of energy embodied in food and fuel and wood and clothing and all the other ways that energy came to people. It was a lot. It took a lot more of their budget, of their monthly budget, the family budget, whatever, than it does now. Um, we spend our money on other things. Um, and the third fact is that right now, oil, and this is for the last few decades, oil has cost somewhere between $60 and $140 per barrel in 2023 dollars. So whatever you think is a good price at the gas tank, at the gas station, um, it hasn't varied. It may have multiplied by two. Sometimes it might have been $4 a gallon once, and at one point $1.50 a gallon another time, but it hasn't multiplied by 10. It's been within a range, and that range is roughly right now between $60 and $140 a barrel. And so as long as we're paying these prices for oil, as long as we're spending 1/20th of our money on energy, as long as we're spending only 1/6 of our energy getting more energy, then we can talk about how much we're likely to leave in the ground and how much energy and when we're going to run out of energy within this framework. Of course, once energy becomes difficult enough to obtain, then our society may make some adjustments and decide that it's willing to restructure. We're willing to restructure ourselves in order to continue getting some amount of energy. We may be willing to send armies underground into the coal mines again, or who knows what else, but a different societal structure, and I can't say anything about that. Okay? I can say about the current arrangement, the current way of life, the current way of organizing our world economy and our private economies within this set of three facts. Then we can talk about an end to energy. Now, of course, to coal, oil, and gas. Now, of course, coal, oil, and gas are minerals. This is one more complication. So they never will run out exactly. So we've been using diamonds and gold, and we've been crazy about them for thousands of years, and still we continue to get more. It's just a question of how expensive they are, how hard they are to get, and how common they are among us. So I want to give an example of copper, and copper is used wherever we use electricity in all our wires. And in 1970, I'm talking about the information known to the United States Geological Survey, which tries to keep track of all the copper and other minerals in the world. It collects information, and in 1970 they knew of or guessed at the presence of 1.6 billion tons of copper worldwide. So there was the amount that they knew about, which was a fraction of that, and then they guessed that there was several times that amount around the world. That's 1.6 billion tons of copper, and then they also think about how much we're likely to leave in the ground. In other words, the amount that is profitable reserves, and it was only a fraction. It was 0.3 billion, so less than a fifth of the total copper that they guessed that there was around the world. 0.3 billion that could be mined at a profit. That was in 1970. Now, 53 years later, 2023, what's the status of copper? Well, since then, all of those 0.3 billion tons that they thought were profitable in 1970 have been mined and used. In fact, twice that amount has been mined. 0.65 tons, 0.65 billion tons. So twice what they thought was profitable in 1970 has since been mined and turned into wires and so on. Furthermore, there's now 0.89 billion tons that they know about that they think could be mined at a profit. So if you take the amount that's already been mined since 1970 plus the amount that they think is remaining that could be mined at a profit, that adds up to around 1.6 billion tons. which is the same amount that they knew about or guessed at. Actually, they knew about only a third of that or so in 1970. They guessed at the presence of another, the amount that they knew about, and then they guessed at 1.6 billion tons. Well, now, but they thought that only a fraction of that could be mined at a profit. Now we care about copper enough, and we are willing to pay enough to get it, that all that copper that they thought wasn't profitable is now considered to be profitable. So we've changed our standards for what we're willing to pay and what we're willing to sacrifice in order to get copper, and therefore now all of the copper that we knew or guessed at in 1970 is up for grabs. It's profitable. Plus, in addition, since 1970, another 4.7 billion tons has been discovered. So that's around 3 times what has been discovered or is guessed at. So now we guess at or we know about 5.6 billion tons of copper in addition to what we already mined, and whereas in 1970 it was only 1.6. So it's more than 3 times as much copper as we knew or guessed at in 1970. My point here is that minerals don't run out. I mean, practically speaking, there is a finite amount of them, but the real question is how much we're willing to mine, and at what expense. And if we keep wanting more, if we're willing to pay more and more for it, we will get more. It's just there will be less of it, or only for the richer people or for certain purposes. It will become more rare or more costly or harder to get for the average person. So what about coal, oil, and gas? Well, we went over oil, and where we are with oil is that for a long time, almost all of our oil is the type called easy oil, which you get from underground lakes, and it comes out. You don't need to do a huge amount of processing to get something that's useful for cars and jet planes and so on. But that's called easy oil, and right now it provides about 2/3 of our total oil consumption, and for 20 years now, the amount of easy oil produced each year has not increased, even though we would like more. Even though we've doubled our investments and multiplied by 4 our investments each year, now it's up like $600 billion a year investing in getting more oil, and we're still not getting more easy oil. We are getting more fracked oil and more oil from natural gas wells, and we've gotten a little bit more oil from oil sands, all very expensive, all risky, and not increasing very quickly. So since easy oil is at its peak, it hasn't increased in 20 years, and sooner or later it's going to start decreasing. Once it starts decreasing, we can expect that easy oil will divide by 2 after some decades. It could be as soon as a decade later after the first decrease, or it could be 30 years later if it tracks. So our energy consumption multiplied by roughly 2 every 22 years. So maybe you would expect once easy oil starts decreasing, maybe it'll divide by 2 in 22 years. Anyway, it's a matter of tens of years, 10, 20, 30 years. It's not any longer than that. Once easy oil divides by 2, since it's hard to get the other kinds of oil, since they're expensive and risky, it require, if things go slightly wrong economically, suddenly people lose their shirt. And since easy oil still produces most of our oil, once easy oil divides by 1/3, there won't be any way for the other kinds of oil to compensate, and our total oil consumption will decrease. So probably the decrease of total oil will start within 30 years. Could be sooner. Could be 10 years. So that's oil, and that brings us up to date with where we were in the last episode. Now let's talk about coal and gas. First gas, and then coal. Let me find the right place. Gas has some difficulties associated with, with it. Natural gas has some difficulties associated with it that oil doesn't. Okay, you get just like oil, you get it out of a well, but it's a gas, which means that it's hard to store. With oil, you just need a container. You dump it in the container, and it's very dense. So maybe you don't need huge containers. Gas, in order to store the same amount of energy, you need a lot bigger containers, or you need to make it very cold so you can liquefy natural gas. If you make it extremely cold, it's very expensive to do. It requires an awful lot of machinery, a huge plant for liquefying the natural gas, and another plant for turning it back into vapor that you can burn. It's a lot of investment. Or the other alternative is to build a pipeline going from the natural gas well to wherever you want to use it, eventually to consumers, pipelines are also expensive. And all this equipment for, say, pipelines, or for liquefying and then vaporizing natural gas is very expensive and takes time to plan, and also it's easy to destroy. So we saw that, I forgot the name, there was a pipeline going from Russia to Germany, actually a set of pipelines, 4 of them, going from Russia to Germany, and shortly after the special military operation began in the Ukraine, I think 3 out of 4 of those pipelines were destroyed. These were extremely expensive pipelines that spent 10 plus years being planned, and all sorts of international negotiations, and it didn't take much. A few divers in the right place, and maybe some assistance from intelligence agencies or something to completely destroy them. So it's a lot different from oil. That's the main point. Another problem with natural gas is that it's not very good for powering vehicles, or it's no good for powering, say, a chainsaw or a gas mower or something, because you need to keep it in a tank, and the tank is too big and too hefty, too bulky, too heavy to fit into a car conveniently. So there's certain kind of for transportation, natural gas is not really useful, and therefore people want oil a lot more than natural gas. In fact, if you're drilling for oil and natural gas comes out, people often just plug the well and move on, because you have 2 alternatives. If there's natural gas coming out of your oil well, even if oil's coming too, you have 2 alternatives. One is to build the equipment to get that natural gas to a consumer, or to just burn the natural gas on site. That's called flaring. You build a smokestack, and not a stack, a stack, and then the natural gas flows to the top of the stack, and you have a fire at the top, and it flares. And that's discouraged nowadays. So people don't want to flare. They don't, and the equipment requires a lot of investment, finding people to invest, and so on. So often you just think, I'll never make a profit on this well. Let's plug it and let's go on and find some place in a different region. Don't even look very close to this well, because if you drill again close to this well, you're likely to find the same combination of natural gas and oil. So as a result, there's a lot more natural gas still underground than there is oil, easy oil or any oil, um, because people just haven't been very interested in pumping it. Except in Europe, Europe's supply of natural gas is already declining. Um, and in particular, natural gas isn't anything anywhere near peaking the way that easy oil already met its peak 20 years ago in 2005, and natural gas is not there. Another thing to mention is that natural gas can be fracked like oil is in the United States. And in fact, most of United States natural gas right now is fracked, um, and uh, and it does, and therefore that right now in the United States there's a natural gas is unusually cheap compared to in other countries. So I should mention also, I already mentioned this before, we get about 12,000 calories per person per day from natural gas. That compares to 16,000 from oil and about 14,000 from coal. Um, so they're all roughly equal. Natural gas is a little bit behind, but right now there's one, since it's cheaper than oil, we use natural gas for our electrical plants, not oil. Um, and there's a big emphasis lately on burning natural gas in our electrical plants instead of coal, because you produce 1/2 as much carbon dioxide. So I expect natural gas to continue increasing. Will continue, especially since oil is not increasing really. Um, um, and the question is, when will natural gas hit its peak? Now, since the supply of natural gas is increasing, since there's still a lot more in the ground, we have no evidence of a peak yet. Um, and so we're certainly statements about the peak of natural gas are on more shaky ground than the peak of oil. Easy oil is already at its peak, and then the supplements to easy oil are very expensive and are not increasing quickly. Um, so we can already talk with some confidence about the end of the peak of oil coming in the next 10 to 30 years, total oil, and we can't speak so confidently about natural gas. What we can do is we can see how fast our natural gas usage has been increasing in different production has been increasing in different countries, and we can see what is known about how much gas is underground in different countries. Also, like in Europe, where there the supply of natural gas has peaked, and I think maybe decreasing, we can say, okay, well, in that specific region, we can speak with some confidence about the decrease of natural gas supplied from Europe. But for the rest of the countries, what we can do is look at geological data and so on, uh, and look at and do some analysis of that geological data and of the consumption and how fast the consumption is increasing, uh, and based on that, make some predictions about when our supply of natural gas will peak, when we'll get to a point where it just doesn't increase anymore, just as easy oil already has. This is more speculative, um, and it depends in particular on guessing how much we're going to drill and pump, how fast we're going to consume natural gas. Because if we if we consume as much as we can, if we multiply the amount of natural gas by 2 in the next 5 years and by 2 in the 5 years after that, something like that, then certainly we'll run out of natural gas sooner than if we maintained our consumption at the current level. In other words, if we pursue a trajectory of doubling our natural gas usage, maybe to compensate for missing oil or whatever, just because we want to have more energy, say for AI or whatever, whatever we want energy for, then natural gas will run out a lot sooner than if we just maintain at the current level. Anyway, there have been many articles by scientists or by technologists. I think these people would generally consider themselves to be scientists. Scientific articles, peer-reviewed, where people tried to do this analysis of how much was left in the ground and how fast we've been increasing our usage, and make different estimates based on how fast we continue to increase our usage. And in general, they all predict that peak natural gas will come sometime around 2030 or at latest 2065. So sometime in the next 10 to 40 years. I didn't do the analysis, and I think it's all more speculative than the analysis about oil. But overall, the message is that there's not enough natural gas to keep us multiplying our energy usage for more than, say, another 20 years. 20 at most. If it's going to peak, and if natural gas alone, and it's less than a third of our total coal, oil, and gas, if natural gas alone is going to peak by 2065, 40 years from now, oil will certainly start decreasing by then. Then we're seeing then certainly it can't be the fuel of another, maybe of one more multiplication by 2 of our energy usage, but not by 4. If we do use it to multiply by 2 our energy usage, that would mean multiplying our natural gas usage by, I don't know, 6. Let's see. No, by 4. Multiplying our natural gas usage by 4, which would be an extreme growth scenario. And then these scientific analyses would predict that we would hit our peak very soon now. So overall, the bottom line is that natural gas, the end is not yet quite in sight, but it's soon. It'll be a little later than oil, but not much later. If you're under 30, you'll see the peak of natural gas. Now we come to coal. Coal supplies 14,000 calories per person per day. It's far more plentiful than oil and gas, and it's far more convenient for transport. Except for transport, it's more convenient for the natural gas for transport, but less convenient than gas is, than oil is. So why is coal more convenient? It's because you can handle it, you can hold it, you can carry it by hand, you don't have to worry about explosions, you can leave it in a pile somewhere for 10 years and it'll sit there, and you don't have to worry about leaking or becoming actually natural gasoline in your car. You can't leave it in your car a year. If you try to drive your car after a year, you'll find that it knocks or even is destroyed. Coal's not like that. Unless there's a lot of coal dust, it doesn't explode. That's why we used coal long before we used oil and gas. Um, Now, coal is a hard one to call because um, we have far more coal on the Earth, and it's a lot easier to get than oil and gas. Um, in fact, 50 years ago, even until 30 years ago or so, it was commonly stated in the press and elsewhere that we had another 200 years worth of coal to burn. Of course, I think that was probably assuming that our consumption stayed constant, not that it continued to multiply exponentially. If it continued to double as it has, probably those 200 years would really be 50 years or something of coal. But still, it's a lot of coal. Um, but right now, it's widely known that we don't like coal um, because it pollutes. It produces more carbon dioxide than burning natural gas or oil, and it produces more smoke. And so there's been a worldwide effort to not use coal. Um, now, um, there's been one exception to that. So around the world since 1985, coal has not been increasing except in one country, which is China. Um, the coal consumption has not been increasing. On the other hand, China has been booming from 1985 onward, and by now it uses 2/3 of its energy is from coal. It uses twice as much energy from coal as it does from gas and oil and other sources. Um, Now there are other countries that do use coal. The next greater is the United States, um, and then there's India. I'm sorry, India is the next greater, and then the United States. India uses about 10% of the world's coal. Um, I think China uses 55% or 60% of the world's coal. Then the United States uses 5%. Europe altogether uses 5%. All the industrial nations use some coal. If you take the major industrial nations of the world, you add up their coal usage, that makes up 90% of the world's coal. So whoever's making steel or operating heavy duty factories, they use coal. Um, but 2/3 of it is being used by China because they needed to fuel their explosive growth, and the cheapest way to do that was coal. China has made some efforts to decrease its usage of coal. There was a time recently during the 2010s when it didn't increase its coal for 7 or 8 years and instead increased its natural gas usage. But it must be that by 2020, by 2019, that they could no longer get the gas and the oil in the quantities that they wanted and as cheaply as they needed. So they went back to increasing their coal usage. So right now, for the last 4 years, it's been on a trajectory to double every 25 years. Before that pause in the coal increases, it was sometimes doubling every. I think there was like one space of 10 years, so when it doubled in 10 years in China. Okay, so we're in a situation where there's been a worldwide effort ongoing for at least 30, maybe 50 years to not increase our coal and to decrease our coal usage. But still the industrial nations are using it, and in particular China, which is now essential to the rest of the world, because the rest of all the rich countries use goods from China. There are the consumer goods that Americans consume are mostly sourced in China. So you take China, you tell China to stop using coal, and suddenly the stores in the United States are empty, and in many other countries. Not just the consumer goods, many other goods. So the whole world needs that coal. We blame it on the on China, but we all need it. And then to the extent that the industrial countries do their own manufacturing, they also need coal. Let's talk about the amount remaining. Now that's a hard one because until 30 years ago, people were saying that we would have 200 years of coal left, or more, but not a lot more. They weren't talking about 1,000 years. They were talking about a couple hundred years. And now people are debating whether we are at peak coal. And even though we haven't used most of that coal. So I want to talk about one specific. Now, the first country to really use coal in a big way was the United Kingdom, the UK. Now, I just want to give them as an example. So they started their industrial revolution sometime around 1780, and in 1871 so they really cared about where their coal was and how much there was, and they were very excellent scientists and technicians and engineers, and so they could figure out where all the coal was, and they measured every coal seam of a width of a height of 40 centimeters or more, and they knew where it all was, and they estimated how much coal they had underground. And in 1871 they said they had 149 billion tons of coal remaining, okay, which would have kept them going for a very, very long time. Now, so there was no end in sight in 1871, but they hit their peak. Coal hit its peak in 1913, 40 years later, and remained at that peak in 1930, and then began decreasing. So if they had continued to use that peak consumption of coal, they could have kept going for 300 years. Instead, it began decreasing, and now they're hardly producing any coal at all. There's a few open surface mines left, but they're basically not producing anything. And in 1968, they revised their estimates of how much coal remained underground. In 1968, they estimated that there were 29 billion, not 149 billion tons consumed and remaining. So by now, they've used 27 billion tons since 1871, 27 out of 149. 2 billion remain underground, and then 120 billion tons have gone missing. That's 4/5 of the amount that they knew about in 1871. So in the UK, they had lots of coal. They knew about it. They knew where it all was. They've used a fifth of it, and then 4/5 of it has disappeared. So between 1871 and 1968, and they just aren't mining anymore. And you could talk about, this is sort of a similar things going on around the world, where people just aren't mining coal, and acting as if there weren't any left, except for some industrial nations which happen to need it. So where I think, of course that coal, the 4/5 that went missing, is still underground. It's still there, but you'd have to send people underground. You'd have to be willing to burn coal that has sulfur in it. You'd have to be willing to take risks. You would have to, and it wouldn't be nearly as cheap as it is now. So what's going to happen to coal? Well, we may seem like we're on track to hit a peak in coal for another decade or two until oil and gas begin to decrease. Okay, because right now we are able to get gas in particular cheaply, and and oil is still not that expensive, um, and so most of the countries of the world are able to to use oil and gas and do without the coal, except for if they're doing some serious manufacturing. But once oil and gas become more expensive, harder to get, then people are going to start using coal again, and they'll remember the old mine that was closed or the old geological survey that showed where there was a coal seam, and they'll start digging coal. And then coal, we'll have two options for coal. Either we'll be able to grow it exponentially for decades, maybe even 30, 40 years, once oil and gas have met their limit, and then it'll hit its peak, or else we'll be able to maintain coal for a century or two. So, um, so what I'm saying is, first, oil will give out um, sometime soon, in the next 10 or 30 years, and it will start dividing, and then soon after that, another 10 or 20 years after that, natural gas will give out, and it will peak and start decreasing sometime in the next 40 years. And then coal may well have seemed to have hit its peak, but once natural gas and oil start decreasing, we'll start finding that we are willing to use coal after all. And we'll have decisions to make about what sacrifices we're willing to make to get that coal. Our society will change a bit, and depending on whether we multiply our coal or multiply our consumption and continue our exponential growth, we might have another 50 years of exponential growth, or maybe 30 because multiplying coal. No, I don't think 50, because coal right now is only a third of our total consumption. So first we'd have to multiply it by 3 just to maintain our current energy consumption. And then if we want to double our current energy consumption, that would be another multiplier by 2. And then we'd be running through the remaining coal really quickly. So coal can't supply that much more doublings. So I think between oil can't supply any more doublings. Natural gas can see us towards a doubling, and coal can see us towards a doubling. Doing 2 more doublings of our energy consumption just seems impossible, even using the remaining reserves of gas and coal as fast as we can. So we'll hit our peak sometime in the next 50 years. That depends on us. If we want to, instead of growing as fast as we can, if we make different choices and maintain or don't grow as quickly, then maybe we'll be able to maintain a level of consumption for 100, 200 years. Maybe something like consumption that we have now, if we just maintained at our current consumption, ran through the gas, and then ran through the oil, and then the coal, and then the gas, then maybe we could continue doing our current consumption for 100 or 200 years. Eventually, our total energy consumption will decrease. Once it does decrease, we can expect it to decrease about as fast as it increased in the first place. So we know very well from the last 250 years that we were able to double our energy consumption every 22 years or so. So we can expect that our total energy, once it finally starts decreasing, will divide by 2 in something between 20 and 30 years, and then divide by 2 again. I don't know how many divisions it'll do, but I would expect at least 2. Maybe it'll divide by 10 eventually. But sooner or later, it'll on its own we'll restructure our society and our expectations. And just like with silver and gold and diamonds, we'll find that some amount of coal, oil, and gas remain on offer, but maybe only a tenth of what we have now. Maybe a fifth, maybe a tenth. But certainly much less than we have on offer now. And then we'll have to think about where else we can get our energy. So what I'm saying is we can expect a peak in our total energy sometime in the next 50 years by 2075. And then we can expect divisions by 2. And there will be enough divisions by 2 that essentially our coal, oil, and gas will still have some of it on offer, but nothing like the amount that we expect today. And then in order to maintain the amount of energy consumption that we're using right now, we'll have to find other sources of energy, which I'll be exploring in the next episodes. The renewables and also our crops. How much extra energy could we get from our renewables and our crops, and or else we'll have to do with less energy. And I've already mentioned in a previous episode that I expect that in the end, given the expense of all the different ways of getting energy, once coal, oil, and gas are in shorter supply and harder to get, we'll decide to do with less energy because everything else is so expensive. Maybe a half or maybe a third of the amount of energy that we're using now. So that's why I had an episode about how less energy is not the end of the world. Having a half or a third does not mean that we all go back to the Stone Age. Okay, so that just gives you an idea of the end of coal, oil, and gas. We can expect it to end. We can expect it to start decreasing within 50 years. We can expect at most we could multiply them by 2 or perhaps 4 in the meantime before they start decreasing, and then and oil is already at its peak. Okay, that's it for today, and in the next episode we'll be on to renewables, to solar, and then first to wind, and then to solar, and then to nuclear. Okay, well, keep coming back, and see you soon.